carbon footprint. So if you do some research here, they say 1 acre of forest effect on greenhouse gases absorbs somewhere between 4.5 and 41 tons of CO2. It also produces 4 tons of oxygen. That's why it's a 10-to-1 ratio. So 1 mile of spacer cable is going to absorb between 10 and 92 tons of carbon dioxide and produce 9 tons of oxygen. And if we try to make some conclusions about this, EPA estimates that the average car emits about 5 tons of CO2 a year. So 1 mile of spacer cable carbon footprint reduction would offset 2 to 18, 2 to 20 automobiles. So longer lines, we got more savings. Every ton of carbon dioxide absorbed is significant. Green spaces counteract a significant quantity of fossil fuel burning by cars, slowing the rate of CO2 accumulation in the environment. We have engineers send us these photos all the time, bald eagles sitting on a line, birds, three-toed sloth in Costa Rica cruising on the line, anteaters, all kinds of stuff. It's really, really impressive, especially when you work in the rainforest and places where we have a lot of animals. Your heart goes out to see them harmed. Getting back to carbon footprint, if you see on the left, it says for every mile of 100-foot right-of-way through a forest, only 12 acres of trees are lost. In the Midwest region, where the average number of trees in an acre is 200, a new 50-mile transmission line would result in the loss of 120,000 trees. So now we're talking numbers. 50 miles, 120,000 trees. That's mind-boggling. Hendrix Spacer Cable can save, again, 225 acres and 48,000 trees on a 50-mile line project. Start adding those numbers up, you get carbon footprint reduction. That's going to be very significant. And if you take a look on the right, the construction of a transmission line carries the risk of wildfires caused by conductor clashing and lines dropping to the ground. We only have to look at the news during wildfire season to understand that this is real. 2022, the U.S. wildfire season saw more than 7.5 million acres of land burned in wildfires. And Hendrix covered conductor effectively eliminates sparks and flashover, thereby significantly reducing the risk of wildfire ignition. Here's the pilot we built in Maine by the border with Canada. 5 poles, 4 spans, couple of dead ends, double dead end angle, a light angle, and a tangent. This during construction. Use our normal method with a lot of modifications. Our service engineers, our service experts will be on hand when we install a 115 kV line or 69 kV line at your utility. There's some photos, double dead end transmission. Look closely, you'll see the arresters there, since you always need a surge arrestor at the intersection of a covered to bare transition, the same as you would put arresters on your riser poles. I see a double dead end. We've got a tangent, a final dead end, and a vertical dead end. Basically, when we built this pilot, we had a company called Exactor come in testing. They did visual inspections and PD monitoring every 3 months, visual inspection of the circuit, checked all connection points of the cable for corona using RF and ultrasonic detectors and compare them to readings. We did a substation inspection, 1-year frequency, examine all poles, spacers, and other hardware. We took some of the stuff down, placed it, we sent it to the laboratory, we checked for tracking, checked for everything. That has gone extremely well. And then we built our first commercial 115 kV line at Liberty Utilities in New Hampshire. These are the photos I got from the field folks. This is it. How do you expand capacity in an existing right-of-way? Here they took a 115 kV right-of-way with a 15 kV underbuild and doubled the capacity in the same right-of-way. So they've got 2 115 kV lines and 2 15 kV lines. Conclusions: 9 kV high voltage covered conductors been in successful operation for a long time, since 1995, both spacer cable and tree wire. It's mechanically and electrically reliable and proven. We've got 69 kV high voltage covered conductor in North America, Canada, South America, the Caribbean. Our 115 kV pilot is almost 4 years old, still in operation. Our 115 kV system at Liberty Utilities is energized. We've had shown the numerous advantages of high voltage covered conductor systems. They're compact, reliable, safe, reduced right-of-way, environmental protection, reduced carbon footprint, ability to add capacity in existing right-of-way, and environmental stewardship, as well as carbon footprint reduction. And if we could say one of many conclusions, the march of covered conductor towards higher voltage classes will continue as existing infrastructure declines. New lines are needed for bulk power expansion, connection to renewables, and powering EV charging sites. This will not stop. I mean, we started in 51. We're in 2023 up about 5, 6, 7, 8 voltage levels, and we're going more. And so this is very exciting. I've been very proud to be part of this, and really happy to present this to our industry.